So let's use an unbundle by name on the servo gyro data in, and use that to pull out the switch off time. Connect that up to our existing wire. Now let's just take a second and clean this up a little bit. So another comment back to style. My personal preference is always to move the label to the left side of controls and to the right side of indicators. You'll notice that it automatically snaps to position when you try and get it close there. That allows you to move these terminals to be very close to each other. You can then use the arrow keys to fine-tune their locations. You can end up with code that is nicely and neatly organized. Same thing goes with the unbundle by name. You can nudge it around using the arrow keys, and that will allow you to remove any kinks that you might see in the wire and keep everything flowing very simply and cleanly and easily to watch. So the next thing we want to do is we have this cluster output. And we remember from the previous video that how we write data into a cluster is using the bundle by name function. Remember, the middle terminal of the bundle by name function is wired to the input cluster, which tells it two things. It tells it what kind of data is present, and it gives it the values from the input cluster. So the gyro read angle comes from that SubVI. We pull the handle down to reveal the servo set angle, which comes from here. Switch off time we're not going to modify. Remember, that was set in another part of the program. We don't want to change it, so we're going to select the switched off parameter and actually connect that up to this Boolean result from the comparison function. And the last thing we need to do is connect the output of that bundle by name to the servo gyro data out. So now that we've completed the SubVI, we can save it and close it. And all we have to do now is replace it in our teleop VI. So all this code that sits here, we can actually delete that because we've just duplicated it. And the way that you place a SubVI you've created is you bring up the functions palette and you choose select a VI. That brings up an open window that allows you to choose the SubVI you want. And see how, because it's in the Team SubVIs subfolder, it's easy to find. So we place that down. All we have left to do is wire up our inputs. So the gyro device ref goes here, the servo device ref goes here, and now we can't connect the switch off time as you might think like this. We get a broken arrow, and do you see why? Well, one of the hints is, in this unbundled by name, we see that there's a very long name for the switch off time. It's no longer just switch off time. It's now, because of this dotted reference, we see that it's inside the pan servo gyro data. Plus, when we created the SubVI, and we can confirm this by using the Control-H context help, we actually wired in the servo gyro data type as an input to the SubVI, and not the switch off time itself. So we actually want to change this. Instead of being switch off time, we want this to actually be all elements for the pan servo gyro. We're going to clean this up a little bit, move these tunnels around to remove any unnecessary branches in our wires, make it easier to see the flow. We've got a lot of extra space here too, so maybe we'll move this up a little bit. One other thing we need to do is we've got the data coming out of the servo gyro SubVI. Well, the whole point of having that come out is so that it can be remembered and looked at later. So in order for that to happen, this wire needs to go somewhere. And where it needs to go is back into our robot data. So if we go to our cluster subpalette, choose a bundle by name, and break this wire into the robot data, and insert a bundle by name there, we're going to replace only the pan servo gyro data in that cluster. Clean things up a little bit. So we see what's going to happen here. The references and the data come in to the gyro servo SubVI. It does what it needs to do, and it spits out any resulting data in this cluster. And that cluster then gets updated in the main robot data. And if we just take a moment and return to the robot main, we see that that value comes out into a shift register so that it's remembered loop after loop after loop. So what we've essentially done here is allowed this SubVI to change the data in our robot main. And that's really important. So now that we've seen what we've done here, remember the whole point of this was so that we could encapsulate our code. We wanted to duplicate this behavior that we've just created for the pan servo and also do it for the tilt. So let's do that now. It won't take very long. What we need to do is exactly duplicate the extraction of the data from the main robot data typedef, but instead of for the pan, this time for the tilt. However, they're in a slightly different order, and just to keep our wires from getting all jumbled and crossed, I'm going to manually select these three items to be in the same order as the pan ones. So the first will be the tilt gyro device ref, all elements. The second will be the tilt servo, all elements. And the third will be the tilt servo gyro data, all elements. And now all we need to do is do a control drag of this SubVI, hook everything up. With nice wiring techniques, this can go quickly and cleanly. We've got a second input to do here. Hook that up. And now you've duplicated your behavior exactly. So to really understand the benefit of this, imagine you made a mistake in your gyro servo SubVI. And you realized, oh, I need to keep track of something else. Say, for example, instead of just the gyro read angle, say you also wanted the gyro angular rate. If we take a look at the block diagram, we see that we have the angular rate as an output here of the gyro. But we need to store that data, we need to do something with it. Well, we can do that very, very quickly. If we edit the typedef for the servo gyro data, we make a duplicate of our gyro read angle and call it gyro read angular rate. Put it in the typedef, close it and save it. It's now available in our cluster. You can hook it up. Maybe clean up your block diagram a tiny, tiny amount and save it and close it. So what just happened was we totally changed the data type going into the SubVI, but it happened in both locations automatically. Plus, if we go back and take a look at our robot data typedef, that gyro read angular rate was automatically placed in both for the pan and the tilt. So imagine a situation where you were doing some control or some analysis for each of 4 wheels. This way, if you want to make a change, you only have to make that change once, and it will automatically propagate to all 4 wheels. And the final task, for those of you who are watching very carefully, is to go and return to the initialized state of the teleop VI and initialize the switch off time properly for both the pan and the tilt servo data. Recall before that the switch off time was just a single value in the typedef. Now we've placed it inside the pan servo gyro data and inside the tilt servo gyro data. So we need to ensure that when we initialize it in both clusters within the main typedef. We can see here that this is indicating that this data is being written into the pan servo gyro data, and we should clean up our code so that we can clearly see what's going on here. And drag this down so that we can, in addition, write the value into the tilt servo gyro data, again in the switch off time parameter. And let's use that trick that we initially learned to make a little bit more space by doing a control drag horizontal. Just rearrange these wires so that everything looks good. And finally connect the shut-off time into both parameters. So in this entry we talked a little bit about some wiring techniques and shortcuts, ways to keep your diagram clean and ways to do wire routing in a very fast and hopefully simpler manner. We also talked about encapsulation, how to make a typedef within a typedef, how to make copies of that for a situation where you need to have different instances of modularized code. Then we talked about how to create your own SubVI, 2 different methods, one using the edit menu, create SubVI, and secondly creating one from scratch. Plus we saw how using a proper modular approach will allow you to make changes in one part of your code that will automatically propagate to all the different copies of it.